I'd like to welcome all of you to another episode of Booth Ross and the Joy of Mathing, episode 12.2. Fun fact, this is my second full time recording this episode because I accidentally recorded it without the audio the first time. Good job, Booth. Good job. So, we're going to go ahead and talk about some special polar graphs for this lesson. Before I do that, though, one thing I want to emphasize to you is that regardless of what equation it's given to you, if you can't remember what it looks like, if all else fails, you can always just make a table, plug in different numbers for theta, and in fact, if you're really concerned, just plug in every single angle on the unit circle and for theta, because those are easy ones for you to do, and then find your radius every single time. So you'll just, like, for instance, if I put 0 in, I'd do 3 plus 2 times cosine of 0. I'd evaluate what cosine of 0 is, which is 1. And so this would be 3 plus 2 times 1, or 5. And then I could plot 0, the 5, 0, and so on. And then you could do that with pi sixth, and do 3 plus 2 cosine of pi 6, figure out what cosine of pi 6 is, multiply it by 2, add 3, and then plot that. Okay? So if worst comes to worst, it's kind of miserable, but you could do that. Okay? So, and it doesn't matter, you don't have to know the shape, you'll figure it out if you just plug in all those values. So let's get down to business, though, to defeat the Huns, or these graphs. Okay, so first type of graphs we're going to talk about are called limaçons. They are in this form where you have an a and b. Now a and b are going to be positive integers where you add or subtract them. Okay, it doesn't matter if this is sine or cosine. They're going to have similar features. So there's the dimpled limaçon, and there's the cardioid, and then there's the looped limaçon. And we'll talk about the dimpled first. So there are a couple different ways. Like I said, you can just make a table if you want. That is actually a way that I sometimes teach it. But another way I want to show you is with our reference graph. So I actually want to graph this function onto a rectangular plane like you're used to seeing. So I'm going to rewrite it, though, as 2 cosine of theta plus 3. I'm going to make this x-axis is my theta. This is my r, is the y-axis. And then if you recall from unit 6, just a few units ago, if there's a number in front of theta that will change your period, but there's nothing in front of theta, so our period will stay 2 pi. This will be pi, this will be pi over 2, this will be 3 pi over 2. The last number right here that you're adding, that tells us our vertical shift. So our midline will be at 3 because we're shifting everything up 3. And then this gives you a vertical stretch, which will also tell us our amplitude. So we're going to go up 2 and down 2. Okay, so it's going to be between 1 and 5. Cosine always starts at the max. So go to the max, pi halves will be down to the midline, down to the minimum, back to the midline, up to the max. Boom. There's your cosine graph. Here's what's cool about this. These coordinates right here are the only ones that are actually that important for you in order to really figure out what this graph looks like. Okay, so one's on the main axes. So we're going to go ahead and plot those. So our radius in this case is 5, and we're at 0 for this first one. So we can go 0, 5. So 1, 2, 3, 4, 5, if I can count. There we go, on 0. Then I'm going to go to pi halves, and I'm going to plot a point I'm going to go up 3 on pi halves. So 2, 3, there we go. And then at pi, I'm just going to go out 1 along pi. And then 3 pi halves, I'm going to go out 3 along 3 pi halves. And then 2 pi is just going to be in the same spot. So what I want you to notice is we're from this first point, we are decreasing along until we get to the second point. So we're getting smaller. So we're not going to go out. We're going in and getting smaller till we get to this one. Okay. And then this one, you're going, once again, getting smaller till you get to 1. 1's going to be the smallest, and then you come back up and loop around. That's what these are doing. They're coming back up and looping around. Okay, so this one's called a dimpled because there's actually a slight little dimple right here. And what we're talking about is that it comes back in a little bit, just ever so slightly. It comes in, and so on. So that's why it's called the dimpled limaçon. Okay, so that's where the reference graph can help. Now on these ones, if you really want to do the table, the values I'd suggest, if you noticed, are going to be just the major axes. So just plug in 0, pi over 2, pi, 3 pi over 2, and really you don't need 2 pi because it's just a repeat. So you just got to plug those 4 in, okay? And you'll get these numbers, 5, 3, 1, and 3. So let's go ahead and do our next limaçon. My favorite one is the cardioid because it looks kind of like a heart, which is precious. By the way, the limaçon dimpled always occurs when A is greater than B. I think I forgot to mention that, so I'm just going to say it right now. So notice this A right here is bigger than that B right there. So cardioids occur when A and B are the same. So we're ignoring the sign in between. Our A is 2 and our B is also 2. So this is when the cardioid occurs. Now I'm going to do a sine graph. It's not going to be much different with sine and cosine. I'm going to go ahead and do my reference graph. So I'm going to do -2 sine of theta plus 2. What you're going to notice is that these are all going to be the same. So I'm just going to go ahead and write 2 pi and pi. I'm not going to write everything else. My midline is 2, like before. So go up 2. My amplitude is also 2. That negative just tells me I'm going to start by going down rather than up. And our highest is going to be at 4, our lowest is 0, and our midline's at 2. So sine starts on the midline when we graph it. We'll go down to the minimum, since it was -2 in front. And that pi will go back up, and then back to up to the maximum, then back down to the midline. So you can draw the graph, but remember, I really only care about these coordinates. That's why my graph looks so ugly. Okay, so cardioid, we're going to go ahead and plot these. So at 0, we go out 2. 0, 0 is 1. We've got pi 2. And we've got, oh, sorry, I said pi halves. I meant is at 0. Pi is at 2. 3 pi halves is at 4, so go 4 along. And then 2 pi, we're back up. Sweet. So you'll know that you have a cardioid graph if there's one point that hits the pole and it only hits hits 0 once. Okay. You'll know you have, with their reference graph, you'll know it's dimpled if their whole reference graph is always above 0. If it touches 0 once, it's a cardioid. Just as a little fun fact. So the way the cardioid works is it looks like a little bit like a heart. So it's a little more intense than the dimpled. Dimple had a very slight little dimple. It has a little more of what you might call a dimple. That's the cardioid graph. Oh, we love it. Love. All right, let's do our last limaçon. So we've got the looped. So looped occurs when your A is less than your B. So this is smaller, which honestly, I don't even remember any of this. I just do my reference points and I figure it out, and I'll show you what I mean by that. Okay, so once again, you can make a table, or you could just go ahead over here and do a quick graph. Once again, I know the period is 2 pi since there's nothing in front of theta. My midline is at 1. The amplitude is 3, so I'm going up 3 up to 4, and then down to -2. And then cosine usually starts at the max, but because this one's negative, we're going to actually start at the minimum. So I'll go minimum to the midline, to the max, to the midline, back down to the minimum. Okay, so those are the most important points. You could actually connect it if you want. We don't need to. I'm not going to do it. So at 0, we've got -2. So we're going to go 0, but we're going to go left 2. And then we're at pi halves. It says pi halves. I'm just going to write a half pi. So remember, pi halves is at 1. So I'll go up 1 along pi halves. At pi, we've got 4. So notice, I'm actually going to stop right here. just to show you something, anytime you have 2 points on the same angle or whatever you want to call it, that actually tells you that this is going to be looped. So that's a way I know it's looped. So it doesn't even matter that I remember, oh, A is less than B. I just look to see if I have 2 points on the same spot. And then 3 pi halves is the last one I need. We're back at 1. Okay, so if you do follow along the graph, I want you to notice that it does actually cross the pole twice, or cross 0 twice. So we're actually going to cross through the pole in this graph twice. And this is how it works. You're actually starting right here at this point right there, the -2, and then you're going through the pole to this point. I made that kind of look a little weird, so let me try that. So it comes through to right there. Then that point goes and connects to this other point, and you connect over here, and then you go through the pole once again, because that's what it's saying right here. After the 3 pi halves, you go through the pole and loop it around. And that's it. There's your graph. Mine looks amazing.